For the fourth project of grade 12 computer hardware, I was tasked to build a circuit that took the input of a 12-button keypad and displayed it on the top right corner of an 8x8 LED matrix. We were also instructed to do it only using register level code. Here is the project functioning. One of the main components of this project was the 12-key telephone keypad. This is a device that has 8 pins, and when a button is pressed, it creates a short between two specific column and row pins. The keypad also has a common pin. If one were to connect the power to said pin, anytime a button was pressed, there would be power coming from both the corresponding row and column pins. My custom shift-out function first works by setting the latch pin low. Then the code pulls the clock pin low. Then the code ANDs the value the user wants to shift out with the mask value, which is equal to 128. If the code is high, a 1 is placed on the data pin. If the value is low, a 0 is placed on the data pin. Then the clock pin is pulled high, which sends the bit to the internal registers of the shift register. Then the mask is shifted right once. This cycle repeats 7 times until the bit is fully shifted out. Then the latch pin is pulled high, releasing all data sitting on the shift register's internal registers.
An important part of this project was to figure out a way to convert the value coming in from the keypad into a value to the matrix. This is done using this code right here. So the value I start with is for my pin A, and that's going to be just an example value. It's going to be 0, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1. So the first one I'm going to do is I'm going to invert it. Then I'm going to shift it up by 1. And it's done in this order because of operator precedence. And then the next thing I'm going to do is going to separate out the column data. And that's going to be, so I'm going to do that by ANDing it with 240. So ANDing it, and that will give me 1, 0, 0, and then zeros here. So I can move this now data to a new variable. I call it the column data here. But then another thing I have to do is I have to separate the row data. So take that same value, the key value, then I'm going to AND it with 15. So separate out the high nibble, left with 1, 0, 0, 0, and 0, 0, 0, 0. Then I'm going to invert that value. So I'm left with 1, 1, 1, 0, 1, 1, 1. Then I'm going to shift that value down by 1. So I'm left with 0, 1, 1, 1, 1, 0, 1, 1. Then I'm going to end it with 15. Get rid of this ugly stuff right here. So ending it with 15. That ends up giving me 1, 0, 1, 1. Then by ORing column data, which is right here, 1, 0, 0, 0, with, oh, it also has 4 zeros on the end, with row data, which is 0, 0, 0, 0, 1, 0, 1, 1. That's going to give me my final matrix value, which I then send to the matrix, and that's using my custom shift out function that I discussed earlier.